Let's understand resistance, resistivity, and Ohm's law in this video. Have you ever been told not to touch electrical switches with wet hands and wondered why? Imagine a 220-volt supply and a wet finger touching a live wire. The shock can be dangerous. This is why we study resistance and resistivity. First, what is resistance? Resistance is a property of a conductor that opposes the flow of electric current. We can measure resistance by dividing the potential difference by the current. So R equals V divided by I. The unit of resistance is volt per ampere, which we call the ohm. Resistance comes because free electrons collide with atoms and slow down. So current faces opposition. The value of resistance depends on the length of a wire, the area of its cross-section, and the nature of the material. We write this as R equals rho times the quantity length divided by area, where rho is resistivity. Resistivity is a material property that tells how strongly the material resists current, and its unit is ohm meter. Microscopically, resistivity equals mass divided by the product of number density, charge squared, and relaxation time. So rho equals m divided by the quantity n times E squared times tau. Current density J is current per unit area. So J equals I divided by A. And the electric field E and current density relate as E equals rho times J. Now a safety example to make this real. When the human skin is dry, its resistance can be 1 times 10 to the power 5 ohm. And when wet, it can be 1500 ohm. Question number 1 asks why this matters for a 220-volt supply and what currents flow. Calculate current for dry skin. I equals V divided by R. So 220 divided by 10000 gives 0.0022 amp. That is 2.2 milliamp. For wet skin, I equals 220 divided by 1500. That is about 0.147 amp or 147 milliamp, which can cause paralysis or death. Let us solve some standard problems to see how formulas work. Question number 1. A copper wire is stretched to make it 0.5% longer. Volume stays the same. What is percent change in resistance? Volume constant means area changes inversely with length, and resistance varies as length squared. So percent change in R is about 2 times 0.5%, giving 1% increase. Question number 2 deals with a block whose rectangular cross sections are A by B, A by C, and B by C, and asks resistance across different faces. The idea is simple. For current through AB, the cross section is A times B. So RAB equals rho times length divided by quantity A times B. And similarly, RCD uses A times C and REF uses B times C. Question number 3 is a hollow cylinder of length L, inner radius A and outer radius B, resistivity rho. If current flows along the axis, the area is pi times the quantity B squared minus A squared. So R axial equals rho times L divided by quantity pi times B squared minus A squared. If instead current flows radially outward between inner and outer surfaces, we integrate shells and get R radial equals rho divided by quantity 2 pi L times the natural log of B divided by A. Question number 4 gives number density 8.5 times 10 to the 28 per cubic meter and mean free time 25 femtoseconds. Find resistivity. Use rho equals m divided by the quantity n times E squared times tau. Substitute m as 9.1 times 10 to the minus 31, E as 1.6 times 10 to the minus 19, and tau as 25 times 10 to the minus 15, you get about 1.7 times 10 to the minus 8 ohm meter. So order 10 to the minus 8. Question number 5 asks, if a heater has resistance 50 ohm and current 3.2 amp, find voltage. Use V equals I times R. So V equals 3.2 times 50 equals 160 volts. Question number 6 gives drift velocity proportional to the quantity e to the power 1/2 and asks the V versus I graph. If Vd varies as e to the 1/2, then current I varies as V to the 1/2, so V varies as I squared. The V versus I curve is a parabola, not a straight line. We also learn how temperature affects resistance. For metals, resistance rises with temperature. Because atoms vibrate more, collisions increase and drift speed drops. For semiconductors, resistance falls as temperature rises because more carriers are freed. The temperature formula connects change in resistance to the coefficient alpha. So RT equals R0 times the quantity 1 plus alpha times temperature difference. So what do we learn from this? We learn that resistance is a simple ratio of voltage to current. Resistivity is a material property, and geometry controls resistance through R equals rho times length divided by area. Let us quickly remember. Dry versus wet skin shows why safety matters. R equals V divided by I, and R equals rho times length divided by area. Keep exploring problems to build intuition. Try the resistor color code example to read real resistor values. Thank you for listening. Keep studying step by step and visit EduRef for more practice and clear notes. You are doing great.